Hello students, today we will start our session with remainders. Lot of learning today. So remainders contents. So level 1 9 questions, level 2 4 questions, level 3 3 questions. We will do all these questions. And once we have completed level 3, we will be at a good position to solve any question on remainders. So we will be doing textbook questions, 6 questions. Textbook is basically the Cengage book, 6 questions on that. And then JEE Mains 2021, 6 questions we will be doing previous year questions on remainders. So by the time we are done with level 3, we will be very comfortable in doing textbook and previous year questions. One is this. These 6 questions I've selected, I filtered out. Basically, there were 16 some sets of JEE Mains 2021. So I filtered out the particular 6 questions on remainders. Uh, a brief thing I want to tell you. So basically for remainders, usually there are 3 methods. One is the modulo operator. Second is binomial theorem. And third is what I will be teaching you today. So you can call it the REM function or simply remainders, okay, remainder properties. So this is what I will be teaching you today. So in my opinion, all the questions that require modulo operator can be solved by this REM function. So you need not study modulo operator at all, just solve it by REM function, which I will be teaching you. So 4 to 5 properties, you need to know them. And certain questions have to be solved by binomial theorem only. So there are a couple of questions in today's 22 questions total. Couple of questions are there in which we will use binomial theorem. So certain questions require binomial theorem compulsorily, but broadly remainders can be done by this remainder function that I will be teaching you today. Okay, why I have chosen remainder and not modulo? So I found my remainder function this to be more flexible, more intuitive. That's why I've chosen this. You will be of the same opinion once you learn these concepts post the session. So it's going to be a lengthy session because 22 questions are there. So 1.5 hour at least I'm expecting. I'll be teaching you. And it is very beneficial because you'll see certain questions. So the 6 PYQs of JEE mains, uh, solution by binomial to these particular problems is very complicated, and solution by remainders, once you will learn the concept, will be very simple, very intuitive. So instead of, we can actually avoid those binomials and solve our questions just by the concept of remainders, which will be very intuitive to you, and you will be a boss on professional in this once you have solved all the 22 questions. So my suggestion to you is I will solve these 22 questions in this session and you solve these 22 questions by yourself at home. So you will learn it better. So you will know the benefit once you will start doing the JEE Mains 2021 PYQs. You will know the benefit of learning remainders because you will not need to know binomial then. And lastly, so not only JEE Mains, certain questions on JEE Advanced also that use concepts of remainders. So you will be thorough with the concepts of remainders for JEE Advanced as well. So let us proceed, students. So I will explain you about REM, the remainder function or remainder simply. Okay, there are 4 to 5 properties of REM which we need to know, and I'll be telling you these properties as we proceed. Okay, so just a basic definition of REM. So REM of A by B is equal to 1. This is the representation I'm telling you. So what does this mean? So basically A here is the dividend. A is the dividend. B is the divisor. Very intuitive. B is the divisor. The quotient I have not written it right now, but let us say quotient is represented by Q. We need not write the quotient over here because remainder questions mostly don't require us to know the quotient. And R is the remainder, of course. So this is the representation. Let me see. Okay. So can I highlight this? I'm just seeing if I can highlight this. Never mind. Okay. So see, A by B is equal to N. What does this mean? So say remainder of 32 with 7. What is the remainder of 32 with 7? So 7 into 4 is 28. The remainder is 4. So remainder is 4. So here I will just say dividend A is 32. Divisor B is 7. Quotient is 7 into 4 is 28. Quotient is 4. And remainder is also 4. Simple. So this is the representation. Very intuitive representation. Remainder of 32 with 7 is 4. Another representation that you should know, which is used in certain questions, is the basic form which you have already studied in 8th class. Okay, so I'm just repeating it here because it is useful in certain questions. So dividend, this is equal to divisor divisor into quotient plus the remainder. This is something you have studied in 8th class, but it is useful. So see, dividend is equal to 32, divisor is 7, quotient is what? Quotient is 4, and finally remainder is 4. 32 is equal to 7 into 4 plus 4. 32 is equal to 28 plus 4. Now, this thing is useful for certain questions. So, when I teach students factor theorem, when I teach students factor theorem or remainder theorem, this is the form I tell to students because it is useful over there. Certain questions of remainders in today's session will require compulsorily for us to know this form. Okay, so just remember this form. So this form is used basically when the quotient is involved, and when the quotient is not involved, for most of the questions we will be using this form. So let us start with the first question. As we will progress in the question, the 4 to 5 properties of this particular function we will get to know, like it is distributive and then the negative remainder. So that we will get to know and we'll learn on the way. So let us start now. Level 1 questions. So level 1 questions are basically these 9 questions, but you can do it within 1 to 2 minutes. Okay, and once you are say expert in this, within 30 seconds you can do these questions. It will take me time to explain it to you though. Okay, so I will take time to explain it to you because I'm making the foundation for you people for this remainders. So let us start. So how I will represent it? Here dividend is 2 raised to power 60 and divisor is 5. So I know the representation REM, remainder of 2 raised to power 60 with 5. Okay, so now how to proceed? Just see what we will do. We will observe the powers of 2 and we will note that power of 2 which is closest to 5. So 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, go on. Usually we want such a power which is either a multiple of divisor, which rarely happens because in that case remainder will be 0, or it is plus minus 1 with the divisor. So here if you see, this is 2, 1 second, this is 4, this is 8, and this is 16. So 16 over here is clearly what we are looking for because 16 gives a remainder of 1 with 5. It gives a remainder of 1 with 5. So what fact we will use? So we will use the fact that remainder of 16 with 5, this is equal to 1. So we will use this fact to answer this question. See how very simple. So remainder of 2 raised to power 60 with 5. So this is remainder of, so 60 we know is 4 into 15. So I will write it as 2 raised to power 4 raised to power 15 divided by 5, because 4 into 15 is 60. Very nice. What is the next step? Next logical step is, okay, so let me write it as remainder of 16 raised to power 15 with 5. Okay, this I have written. Now coming to the next step. So next step is basically a property, very intuitive property. Let me check one thing, students, if highlighter is available over here. Highlighter, rubber is there. Okay, so highlighter is not there, no problem. So I will write, what I will do, this is the next property, first property. So this 16, I will replace this 16 with 1. I will replace this 16 with 1. Basically, I am replacing the number 16 with its remainder with 5. So I am replacing 16 with 1 divided by 5 raised to power 15. So this is the property that you can replace the numbers with their remainders, So 16 had a remainder of 1 with 5, I replaced it by 1. So this property we will remember, this is a fundamental property. Now it is very easy. So remainder of 1 raised to power 15, I am writing the complete step initially. This is remainder of 1 with 15. Remainder of 1 with 15, we already know what is it. It is 1. So answer is 1. So we got our answer, which is 1. So I hope students it is clear to you how we proceeded here. So what you can do is that I will not repeat it now because similar questions are ahead. You can just repeat it in the YouTube, okay, and see what I have done. So only one property I used over here. One second. So only one property I used over here, which was that replacing this 16 with 1. I replaced this number with its remainder, 16 with 1, and I got my answer. Okay, let us move on. This is a simple thing, everybody understood this. Answer was 1. In the next question also, similar question, let us do it. So I have explained you to the property. Remainder of 7 raised to power 84 with 342. So the moment you see 342, a bell should ring that okay, I know about 343, which is the power of 7, so that will help me here. 7 raised to power 1, 7 raised to power 2, 7 raised to power 3. So I'm increasing the pace now, okay? Because I feel you people are understanding. This is 7, this is 49, this is 343. So this thing 343 will be helpful to us. So all I need to do is break the power 84 into multiples of 3. So here fortunately 84 itself is a multiple of 3. So you do it like this, remainder of 7. So what is 84? 3 into 28 is 84. So I will write it as 7 raised to power 3 raised to power 28 divided by 342. Okay, let's move. So this is remainder of 343 raised to power 28 divided by 342. Till now I have applied no property, but now I will apply that property, that I will replace the number 343 since I know remainder of 343. I'm writing it, otherwise you can do it in your mind also. 343 with 342, this is equal to 1. So I will simply replace, I am simply replacing 343 with 1. So I replace 343 with 1. This is 1 raised to power 28 by 342. So this becomes remainder of 1 with 342, which is nothing but this is 1. So this is equal to 1. So that is why students answer is 1. So this is the solution. Answer is 1. Simple property, only one property I use. I replace this 343 with 1. Basically replace the number with its remainder with 342. Okay. So replace the number with its remainder. You can do it to simplify. So this is one property we have learned. Let us proceed now. Okay. Now in the next question, we will learn two properties. So we will, in this question, we will learn the concept. So previous question is clear. Answer was 1. Pretty easy. Now in this question, we will learn two properties. First property is that remainder is associative. Sorry, remainder is distributive. Remainder is distributive. So see, remainder of a plus b with n, this is equal to remainder of a with n plus remainder of b with n. Simple meaning of distributive. So a plus b becomes a and b. So we can separate it. Remainder of a plus b with n is remainder of a with n plus remainder of b with n. So this is one property, simple property. I think everybody understands this. So this is the first property that we will use. So I will write rem 71 raised to power 71. Ask to students, I think it will go until 2 hours because the questions are a lot. But we will understand every aspect of every question that can come through remainders. So this is 71 raised to power 71 plus 71 divided by 72. Okay, so using the fact that it is distributive, okay, so this becomes rem 71 raised to power 71 divided by 72 plus rem 71 by 72. So I simply use the property that remainder is distributive. So this is intuitive now. Okay. So the thing is that only. So these properties are intuitive. You will need not remember it. Now next is the concept of negative remainder. So negative remainder, let me explain it to you in a new slide over here. Wait 1 second. So here only I'm adding a new slide. Insert left. Okay. So negative remainder, what is the meaning of this? This is a helpful tool for us to find out remainder. So this is just a tool. So for starting, uh, say there are certain numbers which give a remainder of say 3 with 4. So certain numbers are there which are of the form 4k plus 3. Okay. What are these numbers? These are the numbers which give us a remainder of 3 with 4. So let me write down some numbers. So you can start with k equals 0. So 3, then 7, then 11, then 15, 19, and so on. Okay. Now same thing 4k plus 3, instead of k, I can replace k by k minus 1. I can, since k is any multiple, I can replace k by k minus 1. So this becomes 4 into k minus 1 plus 3. So what does it become? This becomes, so I replaced k by k minus 1. This became 4k minus 4 plus 3, which is 4k minus 1. So essentially 4k plus 3 and 4k minus 1 are the same thing, because both will give the same set of numbers. Okay. So what was 3 over here? What was 3 over here? 3 was the remainder of our number with 4. Okay. So similarly I can say minus 1 is the remainder of our number with 4. So basically, if you say that a certain number n, if a certain number n, like 3, 7, 11, 15, 9, it gives the remainder of 3 so with 4, then you can equivalently say that it gives the remainder of minus 1 with 4. So this is the broad concept of negative remainders. So writing it like minus 1 helps us in simplifying the remainders which we are doing. So I think this much explanation is enough for you students to understand. And where does it come from? So it comes from here. So you can say that remainder of n with say something like b. It is the same as remainder of bk plus n with b. Okay, so this is from where this thing comes. So since remainder of n with b is same as bk plus n, so you can write n as, so in this case, you can write n as what? You can write n as say 4k, 4k plus n. Okay, and so this is basically, students, you need not go into this. I think you need not go into this. Just remember that we can use negative remainders, and I have shown you the principle here just by replacing k and k minus 1. This will confuse you, so I'm just leaving it. Okay, it is negative remainder property is very intuitive. Replace k by k minus 1. So if you have something like, so here it is important that we learn some examples on it. So see, so example on it will be, say a number is giving a remainder of say n with 73, it is giving a remainder of say 72. Okay, so n with 73 is giving a remainder of 72. So you can also say that n with 73, it is giving a remainder of minus 1. Okay, so this is how you will use negative remainders. You just replaced 72 with minus 1. Similarly, it need not be minus 1. If you have something like a number n, say it with 7, it is giving a remainder of 5. Okay, so you will take its complement, negative complement. So then you can say very well that remainder of n with 7, this is equal to minus 2. Okay, so 5 becomes minus 2 becomes 5, 72 becomes minus 1 becomes 72. And explanation I've told you, so k replace k by k minus 1, and this happens. So this was the concept of negative remainder, very simple concept, and we will use it on every second question in remainders. So let us come back to this question. So here we have this question. So this becomes REM Now 71 raised to power 71. We know that remainder of 71 with 72, although it is 71 only, but I will can write it as minus 1. So replace 71 with minus 1 raised to power 71 divided by 72. So one property I used that I use the negative remainder minus 1, and second thing of course that I used is the fact that instead of 71 I just replace the remainder here. Okay, so if this is clear, then the question is solved now. And this is REM. Now it is up to you whether you want to keep it as 71. So I need not write it as REM also, because this second part is already solved. So in this, either you can write it as, it is up to you. If you wanted to write it as 71, then also answer will come. If you wanted to write it as minus 1, then also answer will come. So better is that I write it as minus 1, because then you will learn another concept. So I'm writing it as minus 1. So this question has a lot of new concepts. After this, you will be thorough with remainders. Okay, so remainder of 71 with 72, I replaced here minus 1, here also minus 1. Okay, now what is left? Now remainder of minus 1 with something which is odd. Remainder of minus 1 with something which is odd. So minus 1 raised to power something is minus 1 only. So this will become remainder of, I'm just writing this step. Minus 1 raised to power odd is minus 1. So minus 1 by 72 plus minus 1. So remainder of minus 1 by 72, this is minus 1 and then plus minus 1. So the answer is what is? What is the answer coming? Answer is coming out to be minus 2. But you will not write minus 2 in the exam. Okay, minus 2 will not be an option. So you will write the equivalent of minus 2 with 72. So since I told you, so for 72, if the remainders are coming as 71, you can write it as minus 1. Similarly, if the remainder is coming as minus 2, you can write it as 70. It's negative complement. So minus 2 means 70. Okay, and how will you reach 70 in case you are not able to think about this? So you can just add here, you just add this thing, add a 72 over here with minus 2, you will get to 70. Why you can add 72? Because 72 is the divisor. So this answer is 70. So I hope students this is clear. Very simple question, but learning was a lot. Negative remainders you learned that the remainder is distributive, and finally if it is coming, remainder is coming out to be negative, so you can add the divisor to make it positive. So I'm not repeating it. You can go through this, you can just replay this. Similar questions are there ahead, so let us go and solve them. So answer was 70. Okay, now this thing, so let me do it with speed, okay, because we have to catch up pace now. So remainder of, so I am using the distributive property right away. 16 raised to power 27 with 17. Now as you see, questions will be so simple, students. 1 to 2 minutes you will take. I take 15 to 20 seconds, 30 seconds max. Okay, so I use the property that remainder is distributive. Now REM, what will you replace 16 with? You will replace 16 with minus 1, because remainder of 16 with 17, I'm just writing it here. Remainder of 16 with 17 is, although it is 17, but you can write it as minus 1. So I wrote it as minus 1 raised to power 27 divided by 17. Great. What is this thing? This is simply remainder of 37 with 17. So 17 to 2 is 34. So remainder is 3. This is 3. Great. Let's move forward. Now this becomes remainder of minus 1 raised to power something odd. This is minus 1 only. Minus 1 by 17. And this is plus 3. Remainder of minus 1 with 17, we will write it as minus 1 only. Plus 3. So what is the answer coming? 3 minus 1. 2 is the answer. So simple question. 2. Once you know negative remainders, it is so simple. So answer is 2. Answer is 2. Great. So this was this question. Now we are catching up pace. Similar questions are going to be there. And if you're not able to understand yet, rewind it. You will understand simple negative remainder concept. Now let us catch up pace, because then we have to do conceptual questions on this. Okay, great. Another question. Let us solve it. Now see how simple questions are. Remainder of 7 raised to power 2015. 1 second, students. Let me check one thing. Okay, 24 minutes have already passed. 7 raised to power 2015 divided by 9. What to do over here? So either we have two ways. Okay, we have two ways. Either I observe the power of 7. That is more helpful. 7 raised to power 1, 7 raised to power 2, 7 raised to power 3. Okay, what is 7 raised to power 1? This is 7. This is 49. This is very simple, I think. This is 343. Okay, and remainder of 343 with 9, what is it? Remainder of 343 with 9. So for remainder with 9, you just check the digital sum. I hope if you don't know what is digital sum, just Google it. You keep on adding the digits. Okay, so once you add them, say 10 comes, then you add the digits of 10. So it is 1 plus 0, 1. So digital sum is the remainder with 9 for any number. Just Google it. It's a simple thing. So I'm explaining it to you. Just see. So if you have 343, just add the digits. So 3 plus 4 plus 3. What is it? This is 10. Now 10, just add the digits again. 1 plus 0, 1. So keep on repeating this process till the time you have just one digit. You have just one digit. Keep on repeating the process. So this is equal to 1. Remainder of 343 with 9 is 1. We will just use this fact. So this is looking very simple, I think. So this is remainder. So 7 raised to power 2015. Now 2015, I need to break it. So breaking 2015 we have to learn. Okay. So nothing new. So 2015, either you break it properly. Okay. So either you break it properly. So you divide it by 3. You divide 2015 by 3. What will come? So you will see 6, 21, 7, and then 1, 671 into 2 by 3. 6, 21, 7, 671, 2 by 3. So this means you can write this thing as remainder of 7. Okay, so basically what does this mean? We can write 2015 as 671 into 3 plus 2. Okay, simple meaning. So I will write 7 raised to power 7 raised to power 3 to the power 671 into 7 square divided by 9. Okay, now we have to proceed with this. So this should be equal to, so let me complete it here now. Or I will take the next slide. I'm taking the next slide, students. It is required. So we are left with this thing, okay? Remainder of 7 to the power 3 raised to power what? 671. Although it doesn't matter. 671 into 7 square by 9. Into 7 square by 9. Okay. So now we know this thing is equal to what? This is equal to remainder of 343 raised to power 671 into 7 square, which is 49, divided by 9. Okay. Now next step we know I will replace 343 by its remainder with 9. So this becomes remainder of 343 remainder with 9. This is 1. 1 raised to power 671 into remainder of, we will replace 49 also with its remainder with 9. So 49 remainder with 9, this is 4. Okay. So I have told you one property, students, that this thing remainders, if they are in addition, then you can separate them. Similarly, if they are in multiplication, so what you will do over here, this thing is already 1. This is 1. So here becomes remainder of 4 with 9. So this is equal to 4. So pretty simple, answer is 4. Answer is 4. I'm just repeating it so that it is clear to you. So first was remainder of 7 raised to power 2015 with 9. So I broke 2015 in like this. 2015 was 671 into 3 plus 2 just by doing division with 3. So right now, although it is a shortcut method that you just see the remainder of 2015 with 3 and you can get the answer, but let us do the long way because it is the very first time you are doing it. So 2015 is 671 into 3 plus 2. So I broke it into power 7 raised to power 3 raised to power 671 into 7 square by 9. Now coming into the next slide. So 7 cube raised to power 671 into 7 square by 9. So 7 cube is 343 raised to power 671 into 49. So this is what our intention, that we get a 343, because we know in the previous slide that remainder of 343 with 9 is 1. Okay. So remainder of 343 with 9 is 1. So I just replaced 343 with 1. This is one thing. Remainder of 49 with 9 is 4. So I replaced 49 by 4. Great. So 1 raised to power 671. This simply became 1. 1 into 4 is 4. So remainder of 4 with 9 is 4. So pretty simple. We found the answer 4. this was the solution. Okay, students, now we will do the next problem. You can rewind it. So I'm just taking a small break. I will try to cut this part in the YouTube video. Okay, because I need to eat something. So we will continue in 5 minutes, or you will not see this part and it will be skipped. Okay. Okay, students, I'm back. So let us proceed now. Okay, so we are doing level 1 questions, and let us complete them fast so that we proceed with the other parts of the video, level 2, level 3, and then textbook and JEE main questions. So I'm thinking that I will be putting timestamps for you people. So for each level, I will be putting timestamps so that you can see that where am I right now. So you can skip to the level 2 if you are very confident with level 1 already. Okay, so now this question, nice variety. Question has a nice variety. Let's see. So 34041 and 32506, when divided by a 3-digit number n, they leave the same remainder. So here in this question, I will be using that long form. Dividend is equal to divisor into quotient plus remainder. So how I will use it? Simple. 34041. This is the dividend. What is the divisor? Divisor is n, which you have to find out. And what is the quotient? Quotient is say q. This gives us a remainder of r. So dividend is equal to quotient into divisor plus r. Great. Similarly, I will say 32506. This is equal to, quotient is same q. No, quotient is not same. Quotient is different. The divisor is same. So quotient is say q dash, and then the divisor is n, and the remainder is r. Remainder is r. So basically, according to the question, we have the same remainder when divided by the 3-digit number n. So divisor is same n, remainder is r, quotient will be of course different. So we have to find out the value of n. So now it seems like complicated question, but you should know the trick. trick is, some of you might have thought it, just subtract this. So just subtract the 2. So what happens here? We get q minus q dash into n. Okay, and let us subtract this. So what is coming? This is 11 minus 6, 5, 3 minus 0, 10 minus 5, 5, 3 minus 2, 1. So 1535. Now q minus q dash into n is equal to 1535. Let me break 1535 once. So what is this? This is 3 into 507. No, not 3. So this is 5 into, since this is a multiple of 5, 5 into 307. So this is 5 into 307. Okay. Now what is the equation I'm getting? The equation I'm getting is n into q minus q dash is equal to 5 into 307. Why I stopped at 307? Because 307, you check, this is prime. So 307 is a prime number. This is prime. So that means we know q minus q dash is some integer, n is some natural number. Okay. So n into q minus q dash, I can simply say n is a factor of 1535. N is a factor of 1535. But since n is a 3-digit integer, so if 3-digit integer condition was not given, I would have got 4 values for n, because 1535 has 4 factors. Either n was 1, 5, 307 or 1535. 4 possible values of n, because n is a factor of 1535. 1535 is 5 into 307. But since n is a 3-digit number, so I will only go with 307. So answer is n equals 307. Pretty simple question. I just made an equation. So this is also a thing you have to learn. Sometimes you have to make the full equation. Dividend is equal to quotient into divisor plus remainder. I got 2 equations. I subtracted them and then I got the answer very easily. So certain questions require this kind of thinking also, that you put the long form. Dividend is equal to quotient into divisor plus remainder. So remember this form. Great, students. We are doing good. Let us proceed now. Anytime you have some doubt, just replay. We have to keep the base. So what is the remainder of n with 12? So this is actually written 12. Okay, so remainder with 12. Very simple. So see, remainder of 1421 into 1423. Very basic question, but I have just put it. 1425 divided by 12. This thing. So even if they are in multiplication remainders, we just replace them by the remainders with a particular number. So remainder of 1421 with 12. This is one thing we have to calculate. So remainder of 1421 with 12, you just divide 1421 with 12. So this is, quotient will be what? 1, 22, then 10, 101, 96. So remainder is 5. Remainder is 5. You can check this simply by dividing 1421 with 12. So here remainder is 5. Here 2 has been added, so 1421 with 1421, remainder of 12 is remainder of 1421 with 12 is 5. So remainder of 1423 with 12 will be definitely 7. Okay, 2 ahead, it is 2 ahead, and this will definitely be 9. Simple maths. Now the thing is that you can replace each of the values. So this is the concept that we have already discussed. So you can replace each of the values with the corresponding remainders. So this is 5, this is 7, this is 9 divided by 12. Okay, let us solve this. So one is that you can multiply 5 into 7 into 9, or you do it like this. Remainder of 5 into 7, you club them, 35 into 9. Let us use our negative remainder concepts that we have learned. Remainder of 35 into 9 divided by 12. 5 into 7 are multiplied. Okay, next is what? So 9 is already simplified. It is less than 12. It cannot be simplified further. 35. So 35, we know 12 into 3 is 36. So either I say remainder of 35 with 12 is 24 plus 11, 11. Or I can also say that it is minus 1. Okay, so since 36, 12 into 3 is 36. So I can say remainder of 35 with 12, this is equal to minus 1. So I am assuming that you have understood negative remainders by now. So this is REM, minus 1 into 9, minus 9 with 12. Now what is minus 9? Minus 9, I wrote it like this. Remainder of minus 9 with 12, minus 9. Okay, so to make minus 9 positive, I will add 12. So minus 9 plus 12, which is equal to 3. So we know remainder of Minus 9 with 12 is same as remainder of 3 with 12. Even if we don't know that, we can simply just add this thing. I simply added 12. I simply added 12 and minus 9 plus 12 gave me 3. So answer is 3. Very simple question. Answer is 3. Answer is 3. So students who have learned it, they can go to level 2 also. So I will put the timestamps so they can go to level 2 directly. So rest of us, let us keep solving. 1 second, students. So I hope you all are enjoying. Okay, this thing. Okay, this is a property. I will make a table over here, a property table. So let me make in a new slide, a frequently used property. So see, I'm making a table. Okay. Okay. Now we have terms like a raised to power n minus b raised to power 10. You remember this table? This is a helpful table, and I will tell you trick, so you will not be needing to remember it. You can recall it just by that trick. So this is this. Now we have two cases: a raised to power n minus b raised to power n, a raised to power n plus b raised to power n. Two forms of numbers. Now one is n is odd, and other is n is even. So we will note this thing. Say for example n is odd. So something like a cube minus b cube. So a raised to power n minus b raised to power n will always be divisible by a minus b. Like a cube minus b cube is divisible by a minus b. If it is a cube plus b cube, okay, a cube plus b cube n odd, then it will be always divisible by a plus b. Like a cube plus b cube is divisible by a plus b. A raised to power n plus b raised to power n when n is odd is divisible by a plus b. Very simple. What about when n is even? So when n is even, this becomes a square minus b square type, a raised to power 4 minus b raised to power 4 type. So in that case, it is divisible by both a minus b and a plus b. So when n is even, a raised to power n minus b raised to power n is divisible by both a minus b and a plus b. Or you can say a square by divisible by a square minus b square. But if it is a raised to power n plus b raised to power n plus b raised to power n and n is even, so something like a square plus b square raised to the power 4 plus b raised to power 4, then it is not divisible by anything. Okay, so there is nothing like a minus b or a plus b that it will be divisible by. So you have to remember this. I have just drawn a graph for divisibility, drawn a table. This is used in questions on remainders. Okay, so just so that you can remember, you can take this case as like a cube minus b cube because it is divisible by a minus b. Here you can take it like a cube plus b cube. You will get to know it is divisible by a plus b. Here you can remember something like a raised to power 4, a square minus b square, or a raised to power 4 minus b raised to power 4 divisible by a square minus b square. And here if it is like a raised to power a square plus b square, it is divisible by nothing. So remember this table, okay, important table. So using this fact, here I have something, the number in the form a raised to power n plus b raised to power n. A raised to power n plus b raised to power n, where n is what? N is odd. So I know when n is odd, a raised to power n plus b raised to power n, it is definitely divisible by a plus b. So this thing is divisible by a plus b. So what is a plus b in this case? So I can simply say, I can conclude that 15 raised to power 23 plus 23 raised to power 23, it will be divisible by 15 plus 23. What is 15 plus 23? 38. So what does this effectively means? It effectively means that I can write 15 raised to power 23 plus 23 raised to power 23. This is equal to 38 into something, into some integer. Into some integer. Great. So if this is the number and we have to check its remainder with 19. Okay, we have to check the remainder with 19. So I can simply say 38 is getting cancelled. So here cancellation is happening. So 19 is perfectly divisible by this number. This number is perfectly divisible by 19 because this is perfectly cancelled out. So I will just say remainder of this number with 19 is 0. because we are getting a 38 over here. It is divisible by 38. So 15 raised to the power 23 plus 23 raised to the power 23 is divisible by 38. 38 is 19 into 2, so it is divisible by 19 also. Remainder is 0. Pretty straightforward question. You people have understood. Great. Similar concept, 0 was the answer. Similar concept is used in this new question. You pause the question, students, and then find out the answer. Okay, so pause it and then find out the answer. It will be more beneficial for you because here it will be checked that how sharp you are. So it's a good practice. So see what we will do over here. If you have attempted it, very nice. 16 cube, we will make pairs. So make this pair. Okay, we will use the same property, but something additional and make pair of these two. So why I am making these two pairs? So see the green pair first. 16 cube plus 19 cube. This is one pair. Then we have 17 cube plus 18 cube. This is the other pair. So a cube plus b cube is divisible by a plus b. So it is divisible by 16 plus 19, which is what? Which is 35. It is divisible by 35. 17 plus 18 is also equal to 35. So 17 cube plus 18 cube is divisible by 35. So all in all, I can say this complete number, since both the parts are divisible by both the parts, red part and green part are divisible by 35, this number is certainly divisible by 35. So this much most of the students would have understood. But the problem is that we are not asking the remainder with 35. We are asking in the question the remainder with 70. So remainder with 70 is asked. So the next step is, which you had to think additionally, if you observe this number x, okay, so you see 16 cube, this is even. Let me write it here. So x is equal to 16 cube. 16 cube is even, 17 cube is odd, 18 cube is even, 19 cube is odd. So even plus odd plus even plus odd. So you club them, club these two, even plus even, it will be even. Then you club these two, odd plus odd, it will be even again. Even plus even will be finally even. So x is even. We have x is even. Okay, if x is even, then x is what? Divisible by 2. Any number which is even is divisible by 2. So we have concluded that the number x, it is divisible by 35 as well as 2. If a number is divisible by both 35 and 2, I can say it is divisible by 70, by 35 into 2 also. So it is divisible by 70. So remainder with 70 is 0. So answer is 0. So very nice question, students. First we use the fact that a raised to power n plus b raised to power n is divisible by a plus b. So we got that the whole number is divisible by 35, and then I use the fact that x is actually even. It is even plus odd plus even plus odd, x is even. So it is divisible by 2 also. So it is divisible by 35 into 2, divisible by 70. So hence remainder is 0. So very nice question. We're going good. Great, student, great. So 0 was the answer. Now we are coming to level 2 questions. You will love the level 2 question also. So let us proceed. Okay, find the remainder when this is divided by 16. So in this question, students, two new concepts I will tell you. Okay, so first concept is simple thing. So if you have any number, okay, say big number, I'm just writing like this. Let me tell it in the new slide. Insert left. Okay, so if you have a big number 3, 4, 8, 2, 3. Okay, so this is a divisibility rule I'm telling you. Some people must be knowing it, and if you don't know, it is okay. Divisibility rule. And this divisibility rule is particularly with powers of 2. So powers of 2. So see, if you have to check the divisibility with 2 raised to power 1, which is 2, you will simply check only the last digit. So you will only check with the last digit 3. So if you have to check for the whole number, you will just take in consideration the last number. Similarly, if you have to take the divisibility remainder with 2 square, then you just check the last two digits. So last two digits 2, 3. So here only last digit. Here you check only last two digits. What does this mean? So see, It simply means, I'm writing it. So remainder of 34823 with 4. This is the same as the remainder of the last two digits with 4. So pretty simple. Okay. So this many people must be knowing. Now, if I ask you next step, remainder of 34823 with the third power of 2, which is 8, 2 cube. So here you will take last three digits. Remainder, so remainder of 34823 with 8 is same as remainder of its last three digits with 8. Okay. So from here we got the rule. So since this was 2 raised to power 2, it was 2 raised to power 3. So it was 2 raised to power 2. That is why I took only last two digits. Since it was 2 raised to power 3, that is why I only took last three digits. Pretty simple. So we can extend this rule and say that remainder of any large number, okay, with say 2 raised to power n, with 2 raised to power n simply means remainder of the last n digits, remainder of last n digits of that number, n digits of that number with 2 raised to power n. So this is the formula that you have to remember. So if it is 2 raised to power 1, just you will just consider last digit. If it is 4, 2 square, you will consider last two digits. If it is 2 cube, then you will consider last three digits. If it is 2 raised to power 4, 16, which is the question, then you will consider last four digits. So for 2 raised to power n divisibility, you just have to consider last n digits. So I hope it is clear, students. Let us move forward. So here divisibility with 16. So by the rule, remainder of this complete number, instead of taking the complete number, we will just take the last four digits and see their remainder with 16. Why this is happening? Because 16 is 16 is, one second student, 2 raised to power 4. 16 is 2 raised to power 4. That is why we are taking last four digits only. So quickly students, now the remainder of 9100 with 16. Okay, we have to calculate this. Now students, I will tell you a new property, okay, which we are learning from this question. So this is simple. You can calculate remainder of 9100 with 16, okay. But there is a new remainder property, REM function property, that you have to learn by doing this problem. So see, I'm introducing a new slide. So this is another property. This property is something that only I have observed that it is true, okay, and it is helpful to simplify calculation. So see, because REM function like that many people use it, but this particular property I have seen never seen. I use it only. So remainder of 9100 with 16, okay. So one is the way that you calculate this and the other is you identify this property, and this is a very important property because I saw that particular JEE main PYQs, they can be done very simply using this property. So this is an important property, okay. I hope that you get the notes. Most probably you should get the notes when I will download it, but even if you don't get it, the clips are with you, okay. So remainder of 9100 with 16. Now the instead of dividing it, students, why don't we cancel it through? So temptation is that we make it 8 and then we make this as 4114550. So this is a temptation that we do it like this, remainder of 4550 with 8. So in REM function, this is allowed, but you have to make an adjustment. So since over here you factored out 2, since you factored out 2 from both numerator and denominator, this 2 factor will go outside the REM function. So this will become twice of REM 4550 by 8. So dividing dividend and divisor by some factor is allowed. Okay, it's not that it's not allowed, but you have to make adjustment. Whatever factor you have divided inside the REM function, it should go outside the REM function, only then your answer is complete. So very straightforward thing, I hope you understood. So let us apply this further. Now I want to divide it further. Okay, so remainder, this 8 you divide by 2, it becomes 4, and this becomes 2. 2, 1, 5 is 7, 1, 0 is 5. So 2 to 7, 5. 2 to 7, 5. 4400 plus 150, 2 to 7, 5 by 4. So now again, since we have divided dividend, both dividend and divisor by some factor, by what factor? By a factor of 2. We will take this factor out of the REM function. So this becomes 4 times REM 2275 by 4. This makes our question very easy. Why? Because remainder of 227 by 5 by 4, you know divisibility rule. For 4, you just have to check last 2 digits. So remainder of 75 by 4, this is actually 72 plus 3, 3. So answer is simply 4 into 3, 12. So instead of doing all that long division 9100 by 16, you can do it like this. You can find out the remainder by using this. So what I did, simple thing, simple property, that whatever by whatever factor you are dividing both dividend and divisor, that factor should come outside the REM function. So this you have to remember. So answer is 12. So answer is 12. Okay, let me do another example so you will learn. Answer is 12. Let us do another example so this is clear to you. So for example, if I say remainder of something where division is happening, say 18 with 16. Okay, very simple, 18 with 16. So answer we know is 2. But what we will do, say we factor out. So this is 8, this is 9. So we had a factor of 2. We factored out 2. This should go outside. So it should become 2 times REM 9 by 8. So REM 9 by 8, we know this thing is 1. So this becomes 2 times 1. 2 times 1, which is actually 2 only. So answer is 2. So we already know remainder of 18 with 16 is 2. We were calculating remainder of 18 with 16. We already know it is 2. But I showed you this procedure so that you know that how this property is working. Okay. So very nice, students. So by now, I think all the REM properties we have learned, and we are in a good position to solve any kind of question. I don't think any particular REM property is left now. Okay, so we have done a lot of learning. Now let's just move on to the questions. Okay, there is the next question. The standard form of question, mostly students will do it. So see 18. 18 is what? 9 into 3. 9 into 3. So we will keep on writing 1 factorial, 2 factorial, 3 factorial. Quickly I'm solving this. Plus 4 factorial plus 5 factorial. So 5 factorial will not have a 9 because it is only, this is 9 into 2, sorry, this is 9 into 2, 18. So 5 factorial will not have a 9. 5 factorial will not have a 9 because it has only 3 raised to power 1. So when the moment you come to 6 factorial, now you know in 6 factorial, you have all the things. So you know that it has 3 raised to power 2 because 3 and 6 it will give 3 raised to power 2, and of course at least one power of 2 is there. So this thing 6 factorial onward, every number is divisible by 18. So we just need to take into account the first 5 terms. So better is that we solve it. So we have to calculate remainder of REM of 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial with 18. So better is you take the sum. So what is it? This is REM 1 plus 2 plus 6 plus 24 plus 120 with 18. What is this? This is REM. This is 153. 153 by 18. So 18 8 the 18 8 the is 144. So this becomes equal to 9. This becomes equal to 9. So answer is 9. Simple question. I know that mostly people would have got it by themselves. So answer is 9. So answer is 9. Great. Next level 2 question. So this thing. So this is one question which will require us to use binomial. So few questions require us to use binomial. So see, by binomial it will happen very quickly. So 576 is equal to 24 square. We have to note this thing. So see, we have to calculate remainder of 25 to the power 10 with 576. Okay, so I will just use binomial, very simple. 25 to the power 10, this is 24 plus 1 to the power 10. And what is this equal to? So you will write 24 raised to power 0 plus 24 raised to power 1 plus 24 raised to power 2, expanding the binomial. And then I'm writing the coefficients. So this is 10C0, 10C1, 10C2. Okay, and so on. So after this term, all the numbers will be divisible. So since we know 576 is 24 square, so after this term, all the numbers will be divisible by 576. They will be divisible by 576. Since we know that 576 is 24 square. So we just have to cater to this thing. Okay, so I can write it like this, remainder of, or you need not do all this also, just see what this number is coming. So you will say 10C0, this is 1 into 1 and this is 10 into 24, this is 240. This thing is 241. So this becomes remainder of 241 plus something which is divisible by, so remainder of the this part, remainder of the part where from where 24 square starts, it will be 0. So answer is simply 241. We just observed from binomial, simple binomial. I just use 25 raised to power 10 is equal to 24 plus 1 raised to power 10. So first two terms, they will give some remainder with 576. After that, since we have 24 square onward, so that the remainder will be coming out as 0. So only focus on the first two terms. So it is 1 plus 240, 241. So 241 is the answer. Very simple question. Simple application on binomial theorem. I had to show it to you. Okay, let's move on. How will you find out the remainder when it is divided by 7? So let us solve this question. So by now we have learned all the required concepts of remainder. So we should be able to solve it by ourselves. I'm confident that students will be able to solve this. Remainder of 15 to the power 2010. So I'm breaking it with 7 plus remainder of, but it is good for practice of negative remainders. So I broke it. Up next part, you people are intelligent, you know. So 15, we will just replace 15 with 1 because 15 is giving a remainder of 1 with 7. So 1 raised to power 2010 divided by 7. Plus over here what will happen? So here we have 16. Okay, so it is giving a remainder of 2 with 7. So I will replace it by 2. 2 raised to power 2011 by 7. Okay, this is fine. So this thing left hand side, this is equal to remainder of 1 with 7. So this is equal to 1. Okay. What can we do over here? 2 raised to power 2011 with 7. So I know 2 cube is 8. So I will use that fact. So 2 cube is 8. So see, uh, either you can write, so for now just write it complete. 2011 divided by 3 if you do. So this is the 3 into what? This says 3 into 6. Or better is that you don't do this thing. Okay. now you are expert enough. So one second. So I'm suggesting you do directly this. Since you know that remainder of what fact we will be using, we will be using the fact that remainder of 8 with 7, that is 2 cube with 7 is 1. So I need to break 2011. I need to break 2011 into parts of 3. Okay. So for that, instead of finding out the full division with 3, you can simply find out what is the remainder of 2011 with 3. So do it like this. What is the remainder of 2011 with 3? So for this, we will just add the terms. So 2 plus 1, 4, remainder of 4 with 3, this is equal to 1. So from here I concluded that 2011 is giving a remainder of 1 with 3. So basically 2011 is of the form 3k plus 1. So here not much effort is required to know that whether the number is 3k or 3k plus 1 or 3k plus 2. Simply by adding the digits, you know divisibility by 3. Simply by adding the digits and then checking the divisibility by 3, you can know. So it is very easy to write 2011 as 3k plus 1 form. Okay. Easy to deduce it like this. No need to find out the k quotient. Okay, so this becomes REM 2 raised to power 2011. So I did it 2 raised to power 3 2011 raised to power k 3k plus 1 into 2 raised to power 1 divided by 7. Okay, so by now I think students must have known the answer. So see, 2 cube, this is 8, 2 cube is 8, remainder of 8 with 7, this is 1. So this whole quantity is 1. So we are just left with 2 over here, 2 raised to power 1, 2. So what will be the answer? Answer will be this 1 plus, so this is 1 into 2, remainder of 2 with 7, so 1 plus 2. So answer is simply 3. So this is new thing that I told you, no need to find out exact values, just find out 2011 is 3k plus 1 or what form, and then you will get the answer simply. Just repeating it, so 15 raised to power, I just broke the remainder first, so I just broke the remainder. 15 has a remainder of 1 with 7, so I put 1 over here, this became 1 finally. 16 has a remainder of 2 with 7, so 2 raised to power 2011 with 7. Now just I have observed that 2011 is 3k plus 1 form. So I wrote it like this, 2 cube raised to power k into 2 raised to power 1. 2 cube is basically 8. So remainder of 8 with 7 is 1. So I replace it with 1. 1 raised to power k is 1 itself. And then we have 2. So 2 remainder with 7, this is 2. So 1 plus 2 is 3. So very easy, very simple. 3. By now I think you people are experts and I think we should level up now. So that is why we have level 3, level 1, level 2 completed. Congratulations students. So if you have been watching the video and solving it, now let us move on to level 3. Okay, so beautiful question can come in JEE main. Okay, so is divided by 13. It's written is divided by 13. So here, uh, basically we will be using some manipulation and then a concept that you all know will appear. So see, take any term. Okay, so take say 3 into 3 factorial. 3 into 3 factorial. So you write it like this. 3, you can write 3 as 4 minus 3, 4 minus 3 into 3 factorial. So this becomes 4 factorial, 4 into 3 factorial, 4 factorial. Wait, 1 second. I did some mistake. 4 minus 1. Sorry, it will be 4 minus 1. So here it will be 1. So it is 3 can be written as 4 minus 1, 4 minus 1 into 3 factorial. So this became 4 factorial minus 3 factorial. Okay, so now I have the idea. Let me write the other terms also. So if I write 2 into 2 factorial, I can write it as 2, I can write it as 3 minus 1. 2 can be written as 3 minus 1 into, 1 second students. So 2 has been written as 3 minus 1 into 2 factorial. So this becomes 3 factorial minus 2 factorial. Similarly, 1 into 1 factorial, 2 minus 1 into 1 factorial. So this becomes 2 factorial minus 1 factorial. Great. So if I have n, so last term is n. Last term is 12 into 12 factorial. So 12 into 12 factorial. This is 13 minus 1 into 12 factorial. So this is 13 factorial minus 12 factorial. So any term in between, just for understanding, sake of understanding, n into n factorial, this would have been n plus 1 minus 1 into n factorial, which can be written as n plus 1 factorial minus n factorial. Now the question is in front of you, and it is your favorite concept, favorite series I should say, which is, all of you know, telescopic series. So this is a telescopic series. Telescopic series are such series in which, uh, although there are a lot of terms, but eventually after cancellation only two terms remain, one from the first term and one from the last term, or maybe four terms. So basically telescope has, so you can say 100 terms are there like a telescope, and you can squeeze the telescope to get just a limited number of terms. So you can do cancellation. So 2 and 2 are getting cancelled, 3 and 3 are getting cancelled, 4 will get cancelled, and then 12 will get cancelled. So sum of this is what? So we are left with 13 factorial and 1 factorial. So 13 factorial minus 1. So this is our value. Now we have to calculate the remainder. So remainder of 13 factorial minus 1 with 13. Now since all of you are experts, you can simply write remainder of 13 factorial with 13. This is 0 because already we have a 13 in 13 factorial, and minus 1 is just minus 1. So this becomes remainder of minus 1 with 13. Remainder of minus 1 with 13. So what does this become? This simply becomes minus 1, and to make it positive we will add 13 plus 13. So answer is 12. So students, the answer is 12. Very nice. If you got it, very nice. 12. So by now you have understood how we use negative remainders and how we make it positive. So answer is 12. Great. Let's move on to the other next question. So students, there is the next question. Have a look at it. This is a good quality question. So basically we just don't have the form a raised to power b. Now we have the form a raised to power b raised to power c. Okay. And so new concept in this, very nice concept. Let us see. So students, don't confuse. So this thing is not written properly. It is 34 raised to power 31 raised to power 301. Okay. It is not, I'm just telling you, it is not equal to 34 raised to power 31 raised to power 301. These are two different things. Okay. So here in this question, this particular value is this and not this, because if they are asking this, then this is equal to what? 34. So we will multiply these two, then 31 into 301. So these are standard form of question. This is a raised to power b form only. This is a raised to power b form, which we have already discussed. So nothing new in this. Okay, this is not the question. The question is this. So here we have a raised to power b raised to power c form, and we will learn some new way, not a property of remainder, but new way to solve such questions. So let us start right away. Okay, so remainder of 34 raised to power something, which is 34 raised to power 301 with 9. Okay, now what we will do? So see, concept is simple only. So you will replace 34 with its remainder with 9. So you know 27 plus 7 is 9. So basically remainder of 34 with 9 is 7. So remainder of REM 7 raised to power 31 raised to power 301 with 9. Okay. So I can say I have 7 raised to power something. I have 7 raised to power something. I have to inquire what is this something. Okay, that something is 31 raised to power 301. Yeah, 31 raised to power 301 is this something. But I have to inquire more about this. So see, first we will see a pattern. So if you have say 7 raised to power 1, and then we have 7 raised to power 2, and then we have 7 raised to power 3, 7 raised to power 4, 7 raised to power 5, and so on. So if we have 7 raised to power 1, remainder with 9 is 7. If we have 7 square, which is 49, so remainder with 9 is 4. So we are going from 7 to 4. If we have 7 cube, then it is 343. We already saw its remainder with 9 is 1. The remainder of 343 with 9 is 1. So once we get a 1 over here, students, once we get a 1 over here, so I can just write 7 raised to power 4. Its remainder is same as 7 cube and 7. So since remainders can be multiplied, remainder with 7 cube is 1. So with 7 raised to power 4, it will be again 7. And it will be with 7 raised to power 5, it can be written as what? 7 cube into 7 square, remainder with 7 cube is 1. So remainder with 7 square, this will come out to be 4. I will just explain what I did over here. So here we had something like 7 raised to power 4, remainder with 7 raised to power 4. Okay, so I wrote it as 7 cube into 7, remainder with 7 cube is 1, so only left thing is 7. Similarly I had I had 7 cube into 7 square for 7 raised to power 5. So remainder with 7 cube is 1, so we are left only with 7 square 49, so remainder is 4. So this cycle will go on, 7 4 1 7 4 1 will go on. 741 741 cycle will go on. Now we can easily solve the question, because if we get to know, so here there is a cyclicity of 3. What does it mean? There is a cyclicity of 3. I think by now some students would have got the answer. So see, observe in 1 2 3 4 5 6. Okay, there is a cyclicity of 3. So basically, if we have the power like 1, it is of the form what? 3k plus 1. Then we have the power 2, it is of the form 3k plus 2. Power 3 3k. Power 3 4 3k plus 1, power 5 3k plus 2, and 6 is 3k. So what we observe is that whenever we have the form 3k plus 1, remainder is 7. Whenever the power is of the form 3k plus 2, remainder is 4. And whenever the power is of the form 3k, the remainder is 1. So all we need to know that this power, the 31 raised to power 301, this power, what is this? This thing is 31 raised to power 301. So all we need to know is 31 raised to power 301 is of what form? 3k, 3k plus 1, 3k plus 2. And then our question is solved. And it is not a big deal to find out this. Very simply, you can just by observing, you can say that remainder of 31 raised to power 301 with 3. So you will just write remainder of 31 with 3, which is 1. It is equal to remainder of 1 raised to power 301 with 3, which is equal to 1. So that means this thing 31 raised to power 301, it is of the form 3k plus 1. It is of the form 3k plus 1. So I can write over here, this is nothing but 7 raised to power 3k plus 1. Okay. So remainder of 7 raised to power 31 raised to power 101, it came out to be 3k plus 1 form. So whenever we have 7 raised to power 3k plus 1, like here or here, the remainder is always 7 with 9. So 7 raised to power 3k plus 1, like 7 raised to power 1 or 7 raised to power 4, remainder with 9, this is always equal to, by the pattern, we can see this is equal to 7. So answer is 7. So I hope students you understood this new type of question. We will discuss it again. Let me tell you how. So basically it is of the form a raised to power b raised to power c. Basically 34 raised to power 31 raised to power 301. Okay. So first I've replaced 34. I've replaced 34 with the its remainder with 9. So 7. I replaced it with 7. 7 raised to power something. 7 raised to power. So I observed the pattern. So 7 raised to power 1, 2, 3. So pattern is that whenever uh, we have the power of 3k plus 1 form, then the remainder with 9 is 7. If 3k plus 2 form, that remainder with 9 is 4. And 3k form, the remainder with 9 is 1. So 741 is repeating. So basically I had to check about the power, that what is the form of the power. It is giving what remainder with 3. So it was giving a remainder of 1 with 3, which was visible from here, from this simple calculation. And therefore the power is of the form 3k plus 1. So I just wrote over here power is of the form 3k plus 1, power is of the form 3k plus 1, that means the remainder will be 7. So answer is 7. So I hope students this is clear. If not clear, just try to do it again. I have explained it thoroughly. You can just replay. So new type of questions, when there is a tower like this, tower of power a raised to power b raised to power c, then what we do, we we look for cyclicity. We look for cyclicity, and this is how we attempt it. So another question. These are level 3 questions. So another question, similar question we will be doing. Answer to this was 7. This was 7. So another similar question, students, we will enjoy it. So this is the question. 32 raised to power 32 raised to power 32 infinite times is divided by 9. We will use the same concept. We will love this concept. So see, REM, remainder of 32 raised to power. So power is something. Say 32. Wait, 1 second. Raised to power 32 raised to power 32 infinite times divided by 9. So first step is what? First step is this, that we will replace 32. We will replace 32 with its remainder with 9, which is 5. Which is 5. So this is 27. 5 raised to power 32 raised to power 32. But with 5, if we will do it with 5, we can make a pattern. 5 with 5, we can make a pattern of say 525. But it is better to do it like this, students. So see. So you can write, as I told you earlier, the we can use negative remainders. Okay. So remainder of 32 with 9 is of course 5. I'm just writing over here. Remainder of 32 with 9. If this is 5 only, but in negative remainders, I can write it as minus 4 also. So this is equal to minus 4 also. So minus 4 will help us more because you will see how. So I will write it as minus 4 raised to power 32 raised to power 32 and so on divided by 9. So why minus 4 will help? First thing is this minus will vanish because minus 4 32 raised to power 32 is something even. So minus 1 raised to power even will become 1. So minus will vanish. So this will simply become equal to REM 4 raised to power 32 raised to power 32 and so on divided by 9. Why I chose 4 instead of 5? Because with 4 it is simpler. Let's see how. So with 4, even with 5 it would be simple. You just have to check the cyclicity. So again same thing. We will check with 4 raised to power 1, 4 square, 4 cube, 4 raised to power 4, 4 raised to power 5, 4 raised to power 6 and so on. Okay, and we will wait till we get a remainder of 1. So we want that power of 4 which gives us a remainder of 1 with 9. Then we are okay. So see, 4 with remainder, 4 is to power 1 remainder with 9, this is 4. 16 with 9, this is what? This is 7. 4 cube is 64. So this is giving a remainder of 1. Very nice. So 4 cube is giving us a remainder of 1. Very nice. Then this cycle will repeat. So 471, 471, this cycle will repeat. So the use of having 4 is that we are getting a cycle of 3. So 4 to 7, 7 to 1. Everybody understood this? Why 4 raised to power 4? Either you can check 2 raised to power 8, 256, a remainder with 9. So you will see that it is 2 plus 5 plus 6, 8 plus 5, 13, 13, 4. So it will be 4. Either you can check it this way or you can just see that 4 raised to power 4 is 4 cube into 4. So 4 cube remainder with 9 is 1. So 1 into 4 remainder is 4. So this is clear. So if it is not, the next step, if it is not very clear to you, I suggest you write it like this. So it is happening 4 raised to power 1. So whenever the power is of the form 3k plus 1, the remainder is 4. Whenever the power is of the form 3k plus 2, the remainder is 7. Whenever the power is of the form 3k, so this comes by practice, the remainder is 1. Similarly, just writing next one, whenever the power is of the form 3k plus 1, the remainder is coming out to be the same, which is 4. So I just have to check that this power, remainder 32 raised to power 32 raised to power 32 infinite times. I just have to check its remainder with 3, and I just have to know what is the form of this thing, 32 raised to power 32 raised to power 32. Okay, and then I'm done with the question. So to simplify it further, so that to help you understand, I'm just writing this is REM of, question is REM of 4 raised to power something divided by 9. So this something we have to see that what is this form. So this form we can just find out from here. So see, what is this thing? 32 raised to power 32 raised to power 32. We have to find out its form. So see, this is REM of. I hope you all are enjoying, students. Abhi, we have to keep up the energy because good questions are coming. This is the last question of level 3, and then we will be doing textbook questions and then actual JEE main level JEE main questions by this new concept that we have learned. So this just replace 32 by its remainder with 3. So if we replace 32 by its remainder with 3, this becomes minus 1. Minus 1 raised to power 32 raised to power 32, because remainder of 32 with 3 can be either written as 2 or minus 1. So minus 1 raised to power 32 raised to power 32, this becomes equal to remainder of, so minus 1 raised to power e1, remainder of 1 with 3. So this becomes equal to simply 1. So from here I have concluded that my power, the 32 raised to power 32 raised to power 32, this thing is of the form 3k plus 1. So my question is solved now. So this is of the form 3k plus 1. So this is of the form 3k plus 1. So I know whenever we have 4 raised to power 3k plus 1 like here or here, the remainder we get is 4. So whenever I have 4 raised to power 3k plus 1, the remainder with 9 is 4. So answer is 4. So I hope students you enjoyed this. Similar thing I did over here only also. So 32 raised to power 32, and basically it was a power tower, and first I replaced 32 with minus 4. First I replaced 32 with minus 4, because minus 1 will disappear because it is minus 4 raised to power something even. Minus disappeared, 4 raised to power 32 raised to power 32. So cyclicity of 4, remainder of cyclicity of power of 4, uh, cyclicity of remainders of powers of 4 is coming out to be 3. So we checked over here, 4 raised to power 1 is giving 4, remainder 4 square is 7, 4 cube is 1, 471 is getting repeated. So I just had to check that the 32 raised to power 32, the power is of what form? Is it of 3k plus 1, this thing? It is of what form? Is it of 3k plus 1, 3k, or 3k plus 2 form? So I just simply did it very simple. I just found out the remainder of power, this 32 raised to power 32 with 3. So this power came out to be 3k plus 1 form. I replaced it over here, and then I knew that 4 raised to power 3k plus 1 form gives the remainder of 4 with 9. So answer is 4. So I hope students this is clear. Now we will proceed with the textbook questions. I'll just have a glass of water and I'll just be back in within 1 minute. So students, we have completed level 1, level 2, and level 3. And we have to start with, so answer here was 4. So we got the answer of 4, and answer was 4 only. Now we have to start with textbook questions. So let me see the content section once. Okay, so we are done with level 1, level 2, level 3. Then we have to do 12 more questions. So students, I think we should abort the class now for now. So you just go through this video, practice all this again. and then I will soon take out another video which will in which I will solve these 12 questions. Okay, so this will give you time also to, so today you can go through this video, and tomorrow I will take out this video in which I will solve textbook questions and JEE mains PYQs. So I'll also have good energy, and you will also be prepared to solve textbook questions and JEE mains PYQs. So students, uh, like the video, and hope you had a good time learning with me. Okay, thank you everyone. So you can wait for the next thing. Next video, part 2 will come tomorrow. Bye bye.